Hello, and welcome to the final section of PyCon. We'll be beginning with a talk by Sam Bishop, who is going to be telling us a bit about Blender and 3D art. They're a professional software developer, an amateur rocket scientist, which I'm told is less impressive than it sounds. They love Python, Django, cats, working on software and hardware, and everything space. Take it away, Sam.
All right. Okay. So, I'm Sam Bishop. I'm a freelance software developer and a consultant as well. I'm also working on space robots at Tetra Orbital. I am here to talk about Blender and Python. Contact details are on the bottom of the slide there, so if you want to reach out to me, you can get to me there. And we'll start with the obvious question. What is Blender? For those of you who aren't familiar, Blender is one of the older open source projects. Initial work started with Ton Rosenthal, an in-house engineer at Neo Geo, which was a Dutch animation studio. And the work started in the December of 1993. The first working build he had that had any kind of feature at all was in 94. In 95, they had their first useful version of it. And the world got its first visual look at Blender in 1998 when they released it as shareware for the SGI IRIX operating system. Which is probably something that some of you have never even heard of. But after the various tech bubble things happened around the end of the year 2000, some bankruptcies happened, some corporate trading happens, and in 2002, Ton is successful in spearheading a public campaign to gather funds and open source the project by buying out the intellectual property. And interestingly, the name Blender actually comes from a song by Swiss band Yellow from their album Baby, which was used by Neo Geo way back in the day as part of Showreel. And since being open sourced, Blender has grown significantly over those 21 years, and it has gained notoriety with things like its open movie projects, which have developed a significant showreel of Blender's capability for itself, and highlighting what can be done with open source software and helping push forward new releases of Blender. Several of these movie projects have involved developing brand new features for rendering and other capabilities Blender did not have at the start of the decision to make that movie. One of the ones that isn't on that slide involves doing rotoscoping and real-time visual effects overlays. There are many features that Blender has pushed forward or significantly improved as part of this active use cycle where they decide we are doing this and they have to make it work. The third one in the top right there, Sintel, was actually a test bed for the alpha version of Blender 2.8. And so they were using the development preview for the entire development of this movie, making sure that every feature that they added and changed in 2.8 was going to be useful for real users when they released. And it's a pretty impressive thing for them to have been doing this for 21 years. And Blender has a lot in it, and I've only got 30 minutes. So I'm going to try and not leave you feeling like this has happened. I'm going to try and actually leave you feeling like you could pick this up and do things, because current Blender has a lot in it. I was not kidding. Blender has a absolutely ludicrous amount of tools inside of it. It has tools for modeling, sculpting, rigging, animation, visual effects. A non-linear video editor like Adobe Premiere is actually inside of Blender. It has multiple rendering engines. It has physics simulations for rigid bodies, cloths, fluids, hair and fur, particles and smoke. And in addition to all of the 3D capabilities, you can see right there, it has 2D vector animation capabilities and editing in a 3D world. So you can actually take your 2D vectors and move them around in 3D to do all kinds of crazy awesome stuff. And you just saw a customization of the rendering there when they did the wonderful sort of Van Gogh effect. And it is just an insanely powerful package. And it is also insanely flexible. In a moment, you're going to see customizations to the UI and extensions to the physics engine, where people have started pushing it and customizing it and scripting it, and in that case, adding new widgets to control it like a gear stiff, to make that swipe turn into a road through a whole dynamic tree of nodes they've customized. And overall, it is one of the most powerful software packages I have ever worked with. You know, it is insane. And it has a Python interface, which you can see right there. That is a capability that does not come stock. He has written his own script there, and that is actually puppeting that model in real time using that Xbox 360 controller like a virtual puppeteer, powered by Python. And speaking of that Python, let's have a look at what Python is inside of Blender. So Python in Blender is actually a full Python installation, just like if you went and downloaded Python 3.10 off py.org and actually had it installed by itself. It has its own complete Python environment, an interpreter, site packages. It comes bundled with several major Python packages from PyPI. It does ship with NumPy, and it has a built-in version of that, and a number of other libraries which help it do significant amounts of data processing that it needs to do thousands of geometry pieces all the time when it's doing things for your animations or rendering or anything else you do with it. And it has its own C APIs, which are bundled up into a Python package that is the Blender API, which they pre-bundle into that Python environment when they ship you Blender. And so there is a lot going on, but at the end of the day, when you actually try to use it as a user, there are three ways you use it as a user. You're either using it via scripts, packages, or add-ons. Add-ons are basically the Blender word for a plugin. We'll get to some of those in a moment. The packages are just like PyPI. Just like any other Python environment, you can download and install. I'll show you a thing to help with that later. It is a little bit clunky to try and do it by hand, but it's not too hard to use just like any other Python packages once you know the right place to do it. But let's start with the scripting because it's the easiest. So I've got a really simple script here. Now, this script is just going to do us a little 4x4 grid of cubes. It's a nice, simple demo. It just shows 2 for loops and a really simple one Blender API call there, the bpy.ops.mesh.primitive. It just chucks a cube in the world. So I'm going to chuck that script into Blender, which will look something like that. And then I'm going to run it and get something like that, which is a very simple demo. It's not visually interesting, but it does show the core principle. You just chuck it in, run it, and there you go. So let's do something more complicated. Let's try and make it more visually interesting. What we'll do is we'll make a bigger grid, and we'll rotate them. So that way we'll actually have a preceding effect where all of them move so that their corners aim towards the origin, and we get a nice kind of a mosaic effect. We'll take some trigonometry at the bottom of that existing loop, we'll make it a bigger grid, and we'll grab that script and we'll chuck it into Blender. Again, it'll look something just like that. And then when you run it, what you'll do is you'll get something that looks more like that. So you can see that as you approach that 0 point on those crossing axes, it aligns towards the center, and we get kind of this mosaic progression effect. It's, again, a fairly simple script, but you can see how that small addition at the end of that little bit of trigonometry gives us something visual. And you can sort of start to think, well, what else can I do? Okay, well, let's take this up to a third dimension. We're on a 3D package after all. Let's do something 3D rather than just kind of a 2D looking thing. So we've got another layer to our for loop. We've got 3 dimensions in play now. And instead of aiming the corners, because it looks a bit better in 3D to do it this way, I switched it over to aiming one of the sides towards the middle. So rather than having sort of awkward edges and corners sticking out, it's a bit easier to see what it looks like when the sides are just aimed towards the middle. And again, we'll take the simple script. It's just got one more nested, slightly different trigonometry at the end. We'll grab that script, we'll pop it into Blender, we'll run it, and then we get something like that, which is a 5x5 grid. And we've got that spread out in space. You can see the inside there. You can see how they're running through and how they all, as it turns around, angles and aims them all in there. Again, very simple script. Did not take long to sit down and just whip this up. Very basic, nothing complicated. Now, let's try and make something a little bit more visually interesting. These have been very basic demos. I'm just chucking cubes in the world. It's not the most interesting thing to look at. So let's try and make something more visually interesting. We'll take the same thing and modify it again. So what we'll do this time is we'll skip anything on the inside of that cube, because it is a cube that we're making at the end of the day. It's a grid of points in 3-dimensional space, but it's full. Let's get rid of the inside. We don't need it. And then what we'll do is, instead of using cubes, we'll use cones. We'll get a more interesting outside look. And what we'll do as well is we'll move it so that it squished together. And then that squished together will overlap and give us like a solid object that we could do something like, say, 3D print, or put it in the world and make it look like a real object. And we'll take that slightly modified script, which is otherwise pretty much the same as the one we just did, the big spread out one, but a couple of parameters modified and one thing swapped for another. So we'll chuck it in Blender again. And what we get when we run it is we get a thwomp sort of looking spiky cube thing, which is definitely more visually interesting than something that we had earlier. But again, it's just a very small modification to a series of iterations, and it's easy to sort of play around with and start getting a feel for how you can make more complicated things with these scripts. I've got a script demo at the end that really shows off how you can stack these things, and that's at the end. So let's go into the add-ons. So Sawcar is a node-based geometry plugin. an add-on, technically, that I was not actually able to run on Apple Silicon, so it is a great one. I've used it before. I've had to grab the GIFs off their GitHub repo to show off the capabilities. It is a useful set of over 250 nodes that you can link together, and I'll explain this nodes and linking stuff in the next slide, or next demo bit. And those allow you to build a series of events chained together that take data in, process that data, produce outputs at the end of that chain that give you various forms of geometry. You can see in a couple of those GIFs, if your eyesight's good enough, that you're manipulating these properties and things change about the geometry in the world because you have direct access to those properties, just like if you were running a script going in and calling the function with a different variable, except those are accessible to you in the UI with nice and easy to manipulate sliders. So, showing this off a bit better will be Sverchok. Now, Sverchok is named Sverchok because that's Russian for grasshopper. And it's a plugin for Blender which was designed to create a similar capability, and it is the older of these two plugins, a similar capability to the node-based editing feature of Rhino, which is a CAD software package, a proprietary one that most people haven't used. But it is a very powerful way of linking everything together in this visual processing way. And they just basically copied the name and picked a different language. So it gives us these nodes, and you can see them down the bottom. And what I've done is I've started with the simplest one I can think of. Give me a box. And then I asked it to go and make that box a rendered object in the world with a nice little pink plastic. Nice and simple. Now, okay, I've just got a box. What can I do with it? Let's bevel the edges of my box. I've grabbed the bevel node. I've chucked the bevel node into the script chain, and then set some properties, and it's beveled my box. Okay, it still looks pretty simple. I've just rounded the corners off. Okay, let's do something more. Chuck in an inset. Chuck in the inset node, and then perform an out inset, which is a little funky until you understand the math behind it, but it pulls these edges out and insets them slightly. And it gives us this kind of cut crystal looking effect, which looked a lot nicer when I played around with it, but it was a bit hard to see on the screen when I did it in like a translucent crystal. So I just stuck with the pink plastic. But it's a good demonstration of how you can chain these things together quite simply and play around with them and manipulate them until you start to get something you like the look of. Now, that's just the basics of using these kind of node-based tools. Where these two add-ons are interesting is that they have the ability to have Python plugins inside of them. So you can write Python scripts, pull those into these two add-ons as nodes, and make your own nodes with Python. So in this case here, I've got a very simple demo. I've got a Python script, this Sverchok attractor here. I'm going to pass the data from that into a pipe, and then I'm going to turn that pipe into a mesh with some properties there. I've picked a bronze material just for example to keep it different. Can't keep making everything pink. So I've got that script here, and that's what that script looks like. There's some stuff in the doc string at the top that tells Sverchok what the inputs and outputs need to be, and then there's just the script for the rest of the block there. Now, when I load that in and I run that chain of nodes in Sverchok, what I get is I get a little fractal attractor there rendered in bronze. It's not fancy, it's a fairly straightforward sort of application. I just found a function that made some points in a line that I liked and chucked it in and made some stuff with it. Now, that's one tiny example, but there are more, because you can build a whole library of these. You can make a whole package of extensions to Sverchok and Sorcar based on this principle. You can build your own library of functions for yourself and import them into Blender for these plugins to use. You can extend the plugins. And there are existing extensions. There are people who have made libraries already, like Sverchok Extra, Sverchok Open3D, and Sverchok BMesh, that have expanded the capability of Sverchok and given it more power than it has out of the box. And that node-based editing can go a long way. So what about getting some basic data in there? There's been a couple of people this weekend talk about data visualization in 3D and various things like that. So let's have a look at some of the data visualization options if you have a bunch of data and you think you could do something pretty with it in Blender. Well, there's multiple add-ons and plugins again. So here are 3 example ones. These seem well supported. They ran when I checked them. Blender Plots, Blender DataViz, and DataFX. But I'll get back to Blender Plots at the end, but I'm going to demo BlendFig, which is yet another one. So what I've gone is I've just used the same Lorentz thing again because I had it handy, and I'm like, well, yeah, I can ask for more dots. Great, more dots. And then I've asked it to do a scatter plot. So with that scatter plot down there at the end, it's just going to do the rendering of our scatter plot. Now, it looks pretty boring right now. It's not the most interesting thing. I think it looked better in bronze, but It is more well-defined, so okay, what can I do with that? Well, I'm going to use Blender's built-in equivalent to Sverchok and Sorkar, because after the success of these plugins, the Blender developers were like, that's not a bad idea. Maybe we should have a thing that does that. And so they built their own, and now we have 3 options on this table, all of which have different capabilities and strengths and weaknesses. There are things that you can do in Sorkar that are not in Blender built-in geometry nodes or in Sverchok's nodes, and vice versa for all 3. So what I've done here just to show off these geometry nodes is I've just taken that mesh, because what I got from the scatter plot was just a straight line of dots connected with, lines. And I've asked Blender to treat it as a curve. And then I've asked Blender to take a star shape from its default primitive box and turn that star shape into a pipe via extruding a curve with the mesh. And then I've asked it to cover it in a blue edged highlight sort of cyberpunk kind of texture. Looks kind of cool. When I get that, it's kind of like a bit of a black hole kind of collision sort of a look, which looks a bit better when you kind of have less clutter around it. But these are just the tips of the iceberg. There is so many plugins out there, thousands on GitHub, hundreds of thousands of scripts that have been written over the years. There is an absolute mountain of content out there for Blender. Some of these are more useful to you as a beginner trying to get started and learn than others, which is why these 2 are the first ones. So Open with IDE is a really tiny one script file. You can just load it like a plugin, and then you get a button that opens those scripts that I was demonstrating earlier in something like VS Code. So you can get IntelliSense, autocomplete, you can install the Blender environment, and it can actually know what those packages contain, which makes it a lot easier to edit bigger scripts like the one at the end. And then there's a script that will easily take care of pip installing for you, because as I mentioned earlier, that self-contained environment can be a little hard to work with sometimes, especially if you have multiple copies of Blender for some reason, like having multiple long-term stable ones because, say, a plugin might not work, which can happen in the open source world, as we all know. So having an easy way to not muck around and reliably go in and make sure that that version of Blender has that particular Python library you want to use is a really handy thing to do. So let's look at a few we can actually use. Again, some of these are add-ons and some of these are packages that you would have to pip install. Their documentation covers that, but I just wanted to show off a few really useful ones that you can play around with without needing to know the ins and outs of Blender super well. So there's Geometry Script, which can automate creating those geometry nodes I showed earlier. If you want to play around with building a big sequence of them, you might want to make that repeatable so that you don't make a mistake when you blow it all away and try and make it again. So you can automate that creation with this library. Then if you do play around with it by hand and you want to kind of reliably reproduce that, well, there's a library to go the other direction. There's Node2Python, which will take a set of nodes and turn them into Python scripts. So you can play around in either direction and still keep these things for working out future versions. There's things like a solar system simulator. Someone was like, I kind of want to make some stuff orbit, but I don't really know how to animate it for that. And I'm like, well, okay, I'll do the physics. And so they put in a Keplerian integrator and did all the physics there with some Python libraries that they install as well. And what you have is the ability to just chuck objects into a Blender environment, give them the correct parameters, and then Blender just orbits them for you. You don't have to do any hard work. It's nice and simple. And speaking of complicated things done simple, molecular dynamics, another visualization thing. So you can load up a bunch of chemical data on, say, a smaller molecule or a complete protein, as is visualized there in the GIF, and it will do a full demonstration of that, including using some math behind the scenes to work out when things should be moving around in sort of a random Brownian motion like some of these things do, apparently. And that adds some of its own geometry nodes in there as well. So another powerful plugin to do this kind of visualization of complicated information. To a more simple version of the information, there is things like a music visualization plugin. So you can visualize music into your environment as either a background effect or tie it into something else. That's just one of their quick little demos. And again, there are so many of these out there that once you start looking, you'll probably find something that does what you kind of want or shows how you can start working it out yourself. In particular, there is an absolute plethora of procedural content generation plugins and add-ons for Blender. And not to mention how many of the various Python libraries you could use to sort of cobble together your own procedural generation tools as well. This tree generator here I actually cover in more detail in a 2021 PyCon AU talk about procedural content generation, which mentions a few other Blender add-ons that can do procedural content as well. And if you do get really into all of this and you do actually want to start showing off to the world how you're doing this all the time, there's actually a Discord plugin. So you can put your current what am I doing in Blender into a Discord. And after showing all of those things, I'm going to use a slightly more visually interesting demo, because all of the demos up to this point have been pretty simple. I mean, sure, that your fractal with the blue was nice, but I think we can go a little bit better with the time we have left. So one final demo. I'm going to pull in NumPy, and I'm going to use that Blender plots library I pointed out earlier, because it does generate plots slightly differently to the other libraries, which is useful for what I want to do in a moment. And then I'm going to use the palatable library, which I've installed via PyPI, which is a library full of plot gradients for when you're generating different plots and want to color all your data correctly. So I've gone and pulled out one of their particular color gradients, and I'm giving it a nice name so that I could play with it later. And I'm chucking in a simple little helper function I use quite frequently to get myself pairs from an iterable. So if I have 1, 2, 3, 4, it'll return a set of tuples to me. So I've got 1, 2, 2, 3, 3, 4. Handy sometimes when you want to kind of build lists of things like this. So now I'm going to give myself another function that's going to generate random points between two spheres. So if I've got like a big sphere and then a smaller sphere, it'll give me a random distribution of dots in the space between them, which you'll see what that's for in a second. So it does a bunch of NumPy stuff, some trigonometry, and it gives me those random points. Now, I'm going to have to get some more information from those points. I'm going to have to work out how to aim them somewhere. So what I'm going to do is I'm going to do some more trigonometry with NumPy, and I'm going to work out how to rotate in the world for Blender to aim something from that random point towards a direction that I want to point it in. And so we've got that function now added to the script here. And then what we'll do is we'll tie them together. So I'm going to generate a list of pairs of adjacent colors, and that's just going to give me a nice little list of tuples. Then I'm going to get a list of how many things I want to put at each step of my script. That's just a little step sequence of powers. And then I'm going to get a list of upper and lower bounds for those spheres so that I get kind of a progressive stacking effect. And then I'm just going to do a single for loop here, and I'm going to generate multiple plots. I'm going to generate the points, rotate them so that it knows where to go, and then scatter plot them using that Blender plot library to do the scatter plot. And when I chuck it all into Blender and just hit the render button to see it with the preview, I get this. And it doesn't look particularly impressive in black and white, but when you see how it turns out with the gradient, I think it actually looks quite good. And that was about 2 hours. It wasn't particularly hard to work out how to put this together once I sort of realized I could do the scatter plot and muck around with the colors and just play around with it in the space. It can be pretty simple to start stacking the things you know into these kinds of contexts and coming up with really interesting things you like the look of. So with all that in mind, that's the last of the demo there, and hopefully you don't feel like you've just watched a tutorial that skips the middle steps. Hopefully you do feel like you can actually try to, start doing some of these things, because these are fairly straightforward starting steps. And there is, of course, time for questions.
Thank you, Sam. Does anyone have a question?
Oh, and I do have it open in Blender if you want to see it and actually see it fully in Blender.
Hi, that was great. Is there a limit to what sort of imports you can put in? Is there capability for adding machine learning based?
Oh, definitely. There are a number of add-ons out there that do things like machine learning on data sets. And one of the things that people have started doing is using machine learning to process the environment. You saw there in that early video that was showing off the 3.6 release, that showreel included someone who'd used a machine learning software package to emulate the Van Gogh style of painting in the rendering layer so that the environment was done in regular geometry, but when it was rendered out, it kind of had that Van Gogh swirly little line effects applied at the final rendering pass layer.
Awesome. Cheers.
Hi there. Is it possible to, from end to end, control Blender from a Python script?
Yes.
As in without touching the interface at all?
Yes.
Just completely.
There's actually a full
CLI.
headless mode.
Oh, perfect.
Which gets a significant amount of use. So it's not like a niche feature like the Chrome headless was for a while. It actually gets used extremely often by people doing large renderings. If you are doing a batch rendering for a movie, you may be rendering thousands of frames. What you'll do is you'll set up your automation pipeline to farm that job out, and you'll use the Blender command line interface to say, render this particular frame from this file. And so they do heavily use it and fully know that it works. Yeah, you could pass a script in and run the script from the outside, generate this, and then render it out if you were to add all the extra camera positioning information and set everything up correctly. I didn't really want to show that because that kind of requires a lot of understanding of the way the 3D spaces work with stuff like rendering and textures and lighting, and it's a bit more than I thought was sort of appropriate for a 30-minute demo when, something like this is actually quite straightforward to show, but at the same time, positioning a camera correctly in the world, lighting it correctly, and showing all the detail can be, significantly more tricky than just having it open and being able to just sort of pan it around so that people can see how it's built up of the layers, because you can see that the different layers get stacked together, creating this sort of progressive effect as it sort of moves out through the stack. Again, it was fairly straightforward to sort of chuck together once I saw one of these libraries do a scatter plot. Yeah. More questions? There's still some time.
Can we have that? Because I could look at it all day.
I'll be putting them online, and if you want, I can try and render a proper one.
Is there support for, sorry, words. What was I asking? It's gone. Having like time-based animations.
Oh, definitely.
To have it, moving and animating.
Yeah, absolutely. There was actually one of the slides had a video, a GIF from one of those packages that has that kind of functionality built in. Let me just jump back to the presentation, and I might be able to quickly jump to it without taking too much of the time that's left. We should have further back here. That one there is actually doing a time-based animation for the music passed in, as well as that one's doing it based on the data from the chemical information. And the add-on here, yeah, there we go. So the Blender Plots library does actually have the capability of doing time-based animations in there as well. So that, and all the way back at the very early one on Orca, that one on the top right corner actually is doing it with the timeline running down the bottom. So that is actually computing some of those properties based on the current frame of the timeline set up. So it's using that frame to determine some of the properties that it passes into the math. So, no, it really isn't, because, like I said, Blender has so many features inside of it that you will routinely forget that it's got those things. Like, I do have to keep remembering it has a full Adobe Premiere-style non-linear video editor inside of it, because why would it need that? Oh, it needs that to composite a complete movie. I think we've still got about 2 more minutes, so feel free.
Time enough for one more question.
Do you know some examples of movies made with Blender?
Oh, yeah. Yeah, that was this slide right here. They've done more than these. There's actually several extra ones. This was just the 9 ones that fit prettiest when I sort of tried to find a set that looked nice on screen together. They've done a number of these. I think they're up to about 15 now. These are all short movies. The one in the middle was hoping to get enough funds raised to try and make a feature-length movie. That didn't quite pan out, but they definitely did make an absolutely spectacular set of fur shaders for that cheap. Really, like you look at the difference in definition between the fur in the sheep in the center and the fur in the fuzzy animals in the top frame above it, and it is a significant improvement in terms of being able to both artistically control the fur as well as have it be a higher definition and less shortcuts necessary to render it. But again, more rendering power with a more recent movie too, so they kind of could cheat a little bit. But yeah, Blender has a lot of these examples out there. I believe it has been used, at least in part, in a number of major movies. I don't have those memorized off the top of my head. I just know I came across them in the list of examples. I wanted to more focus on ones that I knew wouldn't accidentally get any video delisted from the internet. Because these are all Creative Commons licensed.
Thank you, Sam, for this wonderful combination of programming and art.
Thank you.
Here is your customary mug and thank you card.